Okay, we're going to do problem 13 because I think it's one of the more difficult problems. So it says you need about 0.50 grams of a liquid substance, and the balance isn't working to mass material, but you do have a graduated cylinder, which is just a piece of equipment used that I've drawn on the board a couple times that measures volume. Usually has these little tick marks and it measures every milliliter or so. So this is in general what it looks like, but it tells you that it measures every 0.1 milliliters, which means you can measure, because you can have an estimated guess, to the 0.01 milliliter, which is great for this problem. And you also know the density of the material. The density equals 0.85 grams per mil or milliliter. And we know that density equals mass, usually in grams, over volume, usually in milliliters or centimeters cubed, which is great. So the question is saying, how am I going to be able to get this amount of material with this equipment that I have? So I'm going to start by writing down what I have or what I want to end up with. And this is what I want to end up with. Yeah, it's not what you have right now, but it's what you want to get to. So this is what's given in the problem, 0.50 grams. And then I also have two other things. I have a graduated cylinder, and I have the density. Well, the graduated cylinder I know I'm going to use to measure, but I don't have any specific quantity right now. But I do know the density, which will be able to give me the volume that I need. So I'm going to write down my conversion factor, in this case is my density. So for every 1 milliliter, I have 0.85 grams. Make sure to not be confused that density is grams or mass per 1 unit of volume. So there's an imaginary 1 in front of that milliliter. That's why we put it right here. Okay, so if I actually calculate that out, 0.50 divided by 0.85, two significant figures, I will get 0.58823 blah blah blah, which will round to give me 0.59 milliliters because my grams have canceled and I'm left with milliliters. Therefore, the answer to your problem is that you would take the graduated cylinder and measure out 0.59 milliliters. And you're justified in doing so because the graduated cylinder measures to every 0.1 mil, which means that last digit is doubtful. It's the guess. It's the estimated guess that you give. Okay, this is problem 19, which there's not going to be a lot to actually write about. But the question says that methane is burned with oxygen and the products are carbon dioxide and water. So what you can write out to kind of give yourself a visual is that you have methane. It reacts with oxygen. Right now you don't know how to write any of the compounds and their symbols. So we're just going to write their names. And that gives carbon dioxide plus water. Okay, and the principle that you need to know for this problem is the conservation of mass. So that means you know the amount of material that you start with is going to be the same as the amount of material that you end with. Okay, so you started with, so it says if you produce 18 grams of water, so over here I'm going to put, I have 18 grams of water, from 8 grams of methane, so over here I have 8 grams of methane, and 32 grams of oxygen, 32 grams of oxygen. So really it's just filling in the blank. How much carbon dioxide should you end with? And that's the question. How many grams of carbon dioxide were produced? Well, the mass that I begin with should be the same as the mass that I end with. So right now I have 8 grams plus 32 grams equals X. This is my grams of, I'm going to put CO2, carbon dioxide, most of you know that formula, plus 18 grams. And if you actually solve it, X should equal 22 grams. And that is your answer. Okay, last but not least is problem 20. There's just a couple of other variables in this problem that you may have not done in the previous Q equal MCAT problems or thermal energy problems. So the information that's given is that you have a metal block with mass of 7,500.0 milligrams. It's heated to 55.0 degrees Celsius. So it seems like this is its end temperature, but if you read the problem, it says then it's dropped into a tub of water and then reaches thermal equilibrium of 32.0 degrees Celsius. So that means my 55 degrees Celsius is my initial temperature, and my final temperature is that 32.0 degrees Celsius. It says while releasing 550 joules or decimal place joules of energy. When you see releasing, that means that it's given off, which means Q is negative. That is very important in this problem. So you're asked what's the specific heat capacity. So the equation or the formula that should pop into your head is Q equal MCAT. Q equal MC delta T. Now you have all the variables except for C, and that's what you're solving for. So you're going to plug in all of your numbers. And Q is in joules, and that's typical. We like for Q to be in joules, so I'm going to plug that in up here. I'm going to have negative 550 decimal place joules is equal to my mass. Well, my mass right now is in milligrams, and that would be really nice to get it to grams, so I'm not going to show you that calculation, but you'll need to show me calculation going from milligrams to grams when you do this on the exam. So that will give you 7.5000 grams of substance. Then C, which is unknown. And then the change in temperature, which again is T final minus T initial is equal to delta T. So if you did that, you'd find out that your change in temperature, I'm not going to show you that calculation, but is 23.0. Don't forget that decimal place. Pay attention to sig figs. So if I multiply, oh, but there is one thing that I'm missing here, and I just did wrong. My final temperature is 32, my initial is 55. 32 minus 55 should give a negative value. So you'll see with both of these being negatives, the change in temperature and the heat given off, then you will get a positive value for C, which is perfect. It's what you want. So if I calculate all this out, I should get C is equal to 3.19 joules per gram Celsius. What I want you to make sure of is that all of your units make sense. So I'm dividing this numerical value and this numerical value over. They should be underneath the joule. So I have joule right here per, and it should be gram. Okay, I have a gram. And Celsius. I have Celsius. So that's perfect. That's my answer. I box it, and I check my sig figs, which should make sense, and you're done.